In section 7.3, solving two-step inequalities, the essential question is, how do you solve a two-step inequality? Your student objectives in this section will be to learn to solve two-step inequalities, to learn to interpret two-step inequalities, and to learn if a given value makes an inequality true. In example 1a, we're asked to solve the inequality, and we're given 2x plus 7 is greater than 11. So the first thing we're going to do in solving this inequality is we're going to go through and evaluate what terms we have and where they are located in reference to the inequality. So 2x, this is going to be a variable term. I'm going to denote that with VT. 7 is a constant term because it does not contain any variable. We have our inequality sign, and then 11 is going to be a constant term. So what we have here is we have two terms on the right hand side of the inequality. We have a variable term and a constant term, and we have one term on the left hand side of the inequality, which is the constant term 11. Now from here what we want to do is we want to isolate our variable terms from our constant terms. So we want to get the variable terms on one side of the inequality, and we want to get our constant terms on the other side. So in this particular inequality we have only one variable term, 2x. So what I want to do is I want to isolate that on the left hand side of my inequality. I can do that by getting rid of anything else that's over on the left hand side of the inequality, like this plus 7. So to get rid of a plus 7, we do an inverse operation of subtracting 7. Now what we do to one side of an inequality we must do to the other side as well. So I'm going to subtract 7 from that 11. On the left hand side we have still our 2x remaining. Our plus 7 and negative 7 are going to cancel each other out. That leaves me with 0. Then I'm going to have my inequality sign that's a greater than. Then we'll have 11 minus 7, which is 4. Now from here what we do is we see that we have our variable term on the left hand side isolated, and we have our constant term on the right hand side of the inequality. Next what I want to do is I want to break apart the 2 and the x and get the x isolated by itself. Now when you have a 2 pressed up against an x, that means 2 times x. So in order to break this apart, we're going to have to do the opposite of multiplication, which is going to be division. And I'm going to divide this term by what I'm looking to get rid of, which is going to be that 2. Now since I divided the term on the left hand side of my inequality by 2, I'm going to have to divide the term on the right hand side of my inequality by 2 also. Now when I take 2x divided by 2, the 2's are going to cancel each other out, and it's going to leave me with x. I still have a greater than sign because I did divide by two positive numbers, so I go ahead and leave the sign as it is. And then 4 divided by 2 is going to give me 2. So this problem is going to be x is greater than 2. In example 1b, we're asked to solve the inequality 5h minus 4 greater than or equal to 11. So just like what we did in example 1b, we're first going to go through and we're going to evaluate what kind of terms we have in the inequality and where they're located in relation to it. So the 5h, that is going to be a variable term. My negative 4 is going to be a constant term. We have our greater than or equal to sign. And then 11 is going to be a constant term. Now what I want to do is I want to isolate my variable term first. So I have only one single variable term. It happens to be on the left hand side of my inequality. So I want to get this 5h by itself. That means I need to get rid of this minus 4. So in order to get rid of that minus 4, I'm going to do the opposite of subtract. I'm going to add 4. Now what I do to one side of an inequality, I must do to the other side. So I'm going to add 4 to the right hand side as well. Now on the left hand side, the negative 4 and the positive 4 are going to cancel each other out and give me 0. The only thing I have remaining on the left hand side of my inequality is 5h. Then I have a greater than or equal to sign, and when I take 11 plus 4, that's going to give me 15. Now the next thing I want to do is I want to get this inequality solved for h. So I want to isolate that variable term, or that variable h. Now I have 5h, which means the same as 5 times h. So to break apart a multiplication, I'm going to have to divide that term by what I'm looking to get rid of, which in this case is going to be 5. So if I divide the left-hand term by 5, I'm going to have to divide the term on the right-hand side of the inequality by 5 as well. 5h divided by 5, the 5's are going to cancel, and that's going to leave me with h being greater than or equal to, and then 15 divided by 5 is going to give me 3. So my answer to this inequality is h is greater than or equal to 3. Solving and interpreting solutions. You can apply what you know about solving two-step equations and one-step inequalities to solving two-step inequalities. In example 2, we're told Joshua wants to complete the first mile of a 5-mile run in 10 minutes or less, running at a steady pace. The inequality 5 minus p over 6 is less than or equal to 4 can be used to find p, which is the pace, in miles per hour he can run to reach his goal. Solve the inequality, then graph and interpret the solution. So in this particular problem, we're given the inequality 5 minus p over 6 less than or equal to 4. And we're asked to solve this inequality. So what we're going to do is we're going to go through first and we're going to see what terms we have and where they're located at in reference to the inequality. 5 is going to be a constant term. P over 6, that's going to be a variable term. We have our inequality, which is less than or equal to, and then we have our 4, which is going to be a constant term. So what we find in this inequality is that we have two terms on the left-hand side of the inequality. We have our constant term 5, and we have our variable term negative p over 6. On the right-hand side of our inequality, we have only one single term, the constant term 4. So what we want to do in this particular problem is we want to get our variable term isolated, and we want to get it by itself. Now in this particular inequality, the variable term happens to be on the left-hand side of my sign. So what I want to do is I want to get that thing by itself, and I do that by getting rid of this constant term 5. Now this 5 doesn't have a sign in front of it, so it's understood to be a positive 5. So to get rid of this positive 5, we are going to subtract 5 from the left-hand side. Now what we do to the left-hand side of an inequality, we must also do to its right-hand side as well. So I'm going to subtract 5 from that 4. On the left-hand side, the 5's are going to cancel each other out and give me 0. The only thing I have remaining on the left-hand side is going to be that negative p over 6. Then we have our less than sign, less than or equal to sign, and then we have 4 minus 5. Now when I take 4 minus 5, that's going to give me negative 1. Now from here I've isolated my variable term on the left-hand side of my inequality, and I've isolated the constant term on the right-hand side. Now what I need to do is I need to isolate the variable from the variable term. So I need to get this negative p by itself. So what I'm going to do in order to get that negative p by itself is I'm going to multiply this term by 6. In doing so, that's going to allow me to get rid of this fraction and to cancel out that denominator and be left with just a negative p. Now what I do on the left-hand side of the inequality, I must also do on the right-hand side. So I'm going to also multiply by 6 on the right. Now from here, the 6's are going to cancel each other out, and that's going to leave me with negative p is less than or equal to, and when I take a negative 1 times a 6, that's going to give me negative 6. Now with this particular problem, we still have a coefficient or a number that's in front of my variable p. You don't see it, but it's actually a negative 1p. So what I need to do is I need to break apart this negative 1 and this p. Those two numbers are those two things are being multiplied together. So to break them apart, I'm going to have to divide this term by negative 1. Now what I do on one side of my inequality, I must do on the other side as well. So I'm going to divide the negative 6 by negative 1 also. Now when I take negative 6 or negative 1p divided by negative 1, I'm going to get a positive p because the negative 1's are going to cancel each other out. When I take a negative 6 divided by negative 1, that's going to give me a positive 6. Now, since I divided both sides by a negative number, I must take my sign that's a less than or equal to and flip it around to the greater than or equal to. If you'll recall, anytime you multiply or divide by a negative number, you must flip your sign around in order to account for that change there. So the next thing we want to do is we've already solved it here. We have p is greater than or equal to 6. Now the next thing I want to do is I want to go ahead and I want to graph this. So if you'll recall, if you ever have a greater than or equal to or a less than or equal to sign, that means that you are going to have a dot on your number line. Now, if you ever have a greater than or a less than sign without the line underneath it, it means you're going to have an open circle. So with this particular problem, we have that line underneath our inequality, so we have a p being greater than or equal to 6. So what this means is I'm going to put a closed dot on 6, like so, and then I'm going to say that my p values have to be greater than 6 in order to make this inequality a true statement. So what I'm going to do is I'm going to go ahead and draw my arrow to the right of that 6. Now, so it says in our problem, it says solve the inequality, which we did over here in red, with this p being greater than or equal to 6. We graphed it, which is what we did down here, and it says interpret the solution. So in interpreting this solution, what this is saying is that any number that is 6 or larger can be put in place for p in this original inequality, and it's going to make it a true statement. Determining if a given value makes the inequality true. You can use substitution to decide whether a given value is the solution of an inequality. Example 3a. Circle any given values that makes the inequality true. And in this problem, we're given the inequality 3v minus 8 greater than 22, and we're given some values for v. V equals 9, V equals 10, and V equals 11. And we're asked to circle any values of V that we have there given to us that make that inequality a true statement. So what we're going to do is we're first going to start off with writing our inequality, 3V minus 8 greater than or equal to, or greater than 22. And then what I'm going to do is I'm going to come down here and I'm going to say let V equal 9. And then what I'm going to do is in my inequality, I'm going to replace the v with a parentheses and a 9. So that's going to give me 3 times 9 minus 8 greater than 22. Now when I take 3 times 9, that's going to give me 27. I still have that minus 8 greater than 22. Now what I'm doing here is I'm solving each side of the inequality independently of the other one. So I'm going to see what 27 minus 8 is. So if I take 27 minus 8, that's going to give me 19. I still have my greater than sign, and then I have 22. And then once I get down to two values, one on each side of my inequality, then I'm going to evaluate to make sure that that's a true statement or not. So 19 greater than 22. That is not a true statement, so I'm going to put a line through it. And so v equals 9 is not going to be one of those choices that I go ahead and I circle. Now, the next go round, I'm going to take 3v minus 8 greater than 22. I'm going to rewrite my inequality just as it is. Then I'm going to say let v equal 10. So what I'm going to do is I'm going to replace this v in my inequality with a parentheses 10, and I'm going to solve each side of my inequality independently of the other one. So I'm going to say 3 times 10 minus 8 greater than 22. Now when I take 3 times 10, that's going to give me 30 minus 8 greater than 22. Now when I take 30 minus 8, that is going to give me 22. I still have this greater than sign and 22. Now, when I look at this, 22 is greater than 22. That doesn't make any sense. 22 is not greater than 22. It's actually equal to. So we could draw a slash through that line, or through that inequality. And we could say that v equals 10 is not going to be making this original inequality a true statement. So next number, v equals 11, I'm going to start off with my inequality again. I say 3v minus 8 is greater than 22. I'm going to let v equal 11. And then I'm going to replace my v in my inequality with a parentheses and 11. So I'm going to get 3 times 11 minus 8 greater than 22. From here I'm going to multiply. I'm going to take 3 times 11. That's going to give me 33 minus 8 greater than 22. And when I take 33 minus 8, that's going to give me 25. 25 greater than 22. So when I look at this, 25 is indeed greater than 22, so that does check out. So this is the one that we would actually put some kind of box or circle around and say that v equals 11 is the only value there that makes 3v minus 8 greater than 22 a true statement. In example 3b, we're given the inequality 5h plus 12 is less than or equal to negative 3, and we're asked to find which of the given values that make that inequality true. So what I'm going to do is I'm going to start off with my inequality. I'm going to say 5h plus 12 less than or equal to negative 3. Then I'm going to say let h equal negative 3, the first value that I'm given to try. So what I'm going to do is I'm going to replace the h with a negative 3. So I'm going to get 5 times negative 3 plus 12 less than or equal to negative 3. Now just like what we did in example 3a, we're going to solve each side of our inequality independently of the other one. So I'm going to take 5 times negative 3, that's going to give me negative 15 plus 12 less than or equal to negative 3. Now when I take a negative 15 and I combine it with a positive 12, that is going to give me a negative 3. And then my sign is less than or equal to negative 3. Now looking at this, negative 3 less than or equal to negative 3. This indeed does make a true statement with the equal to part. So what we would do is we would go ahead and put a circle or a box around that to signify that that is one of our values that makes that inequality a true statement. Now, just because the first one works does not mean or does mean that the others are going to work as well. So what we're going to have to do is try those as well. So we're going to have to rewrite our inequality 5h plus 12 less than or equal to negative 3. In the next go round, I'm going to let h equal negative 4. So what I'm going to do is I'm going to replace the h in that inequality with negative 4. So that's going to give me 5 times negative 4 plus 12 less than or equal to negative 3. Now when I take 5 times negative 4, that's going to give me negative 20 plus 12 less than or equal to negative 3. And when I take a negative 20 and combine it with a positive 12, that's going to give me a negative 8 less than or equal to negative 3. So comparing those two numbers, negative 8, negative 3, negative 8 is indeed smaller than negative 3, so this also checks out. So we can say that h equals negative 4 is also going to be a solution to that particular inequality that makes it true. Now we're going to have to try this h equals negative 5. So once again we're going to rewrite our inequality. We have 5h plus 12 less than or equal to negative 3. I'm going to let h equal negative 5. So I'm going to replace the h in this inequality with negative 5, and that's going to give me 5 times negative 5 plus 12 less than or equal to negative 3. So if I take 5 times negative 5, that's going to give me a negative 25 plus 12 less than or equal to negative 3. Now when I take a negative 25 and I combine it with a positive 12, the 25 is the larger number numerically. The sign on that is a negative, so my answer will be a negative. And since these signs are different, 25 and 12, I'm going to subtract them. So take 12 away from 25 and that gives me 13. So I wind up with a negative 13 on the left is less than or equal to negative 3. And when I compare those two numbers, negative 13 and negative 3, negative 13 is indeed less than, so that one does check out also. So in this particular example, all three h values that were given to us do make the given inequality a true statement.